Today's lesson's all about properties of arithmetic. I'm going to begin by talking about the order of operations. There are some rules that you need to memorize and follow so that when two people perform the same arithmetic problem and they do it correctly, they get the same answer. I'm also going to talk about some properties of addition and multiplication that are always true no matter what two numbers are involved in the sum or product. After that, Candace is going to come and talk in a little more detail about order of operation. And today's lesson is going to end with Anne getting on the calculator and showing you how order of operation has implications in terms of how you use your calculator. Me specifically, as I indicated, I'm going to begin by talking about the order of operations. Then I'm going to talk about the associative properties of addition and multiplication. I'm also going to talk about the commutative properties of addition and multiplication. I'm going to talk about the distributive property. And I'm going to talk about putting these rules together. Let's begin by talking about the order of operations. Let's consider the simple arithmetic problem 7 plus 3 times 5. Even though this is a relatively simple problem, it's actually rife with danger because two people who haven't learned about what we call the order of operations when calculating this arithmetic problem could potentially come up with two different answers. One person might say, alrighty, you're asking me to find 7 plus 3 times 5. The first thing I'm seeing is addition. 7 and 3 makes 10, and I want to multiply that by 5, and so that gives me 50. And another person might come along and say, you know what? I'd rather do the multiplication first. 3 times 5 is 15, and we need to add 7 to that, and that's going to give us 22. Well, this is a problem. It cannot be the case that 7 plus 3 times 5 is both 50 and 22. So we have to come up with some sort of agreement about which one of these calculations is correct. And the agreement we have is called the order of operations. I'm going to give you a few of the order of operations, and Candace is going to fill in some gaps later on. The first rule in order of operations is that you always perform arithmetic that occurs inside grouping symbols first. The two most common types of grouping symbols that you will see are parentheses and square brackets. The second rule of order of operations for right now is that unless directed otherwise by grouping symbols, you perform all multiplication and division before any addition or subtraction. There's actually some other things that come before this, but for right now, we're just going to consider multiplication, division, addition, and subtraction. Now, this rule says that multiplication is performed before addition. So we already know now which one of these two calculations was accurate. The calculation where the multiplication was done before the addition was the accurate calculation. This calculation here was invalid because the addition was done before the multiplication. After you've performed all your multiplication and division, and before you perform your addition and subtraction, there's a couple things that you need to keep in mind. If you must perform more than one multiplication and or division, you perform the operations left to right. And if you must perform more than one addition and or subtraction, you perform the operations left to right. So let's see several examples of the order of operations. Let's compare 7 plus the product of 2 and 3 with the sum of 7 plus 2 multiplied by 3. In the first expression, since there's no grouping symbols, the first rule I need to apply is that multiplication is done before addition. So the first thing that I'm going to do is I'm going to multiply 2 and 3, which gives me 6. And that 6 needs to be added to 7. And I end up with 13. In the second example, there are grouping symbols. And grouping symbols always take priority. So the first thing I need to do is find the sum, 7 plus 2. That's 9. 9 needs to be multiplied by 3. And 9 times 3 is 27. And notice that these grouping symbols had a big impact upon the value of the arithmetic. Let's look at 4 minus 2 plus 5. One of our order of operation rules says that when you have both addition and subtraction to perform, you need to perform the operations left to right. Let's see if there is really a need for performing the operations left to right. Let's do this calculation left to right and see what we come up with. The first thing I'm going to do is find 4 minus 2, which is 2, and I still need to add 5, and 2 plus 5 add to 7. Was it really important that I did this left to right? Well, let's see what would have happened if we had done the sum first. If we had done the sum first, we would have added 2 and 5, which would have given us 7, and that 7 would have needed to be subtracted from 4, and holy smokes, 4 minus 7, it ain't 7, it's negative 3. So it really did make a difference, the order in which we performed these operations. And because order of operation says that subtraction and addition have equal priority, and what that means is that if you encounter both addition and subtraction, they need to be performed left to right. The first calculation was the correct calculation. The second calculation was just plain wrong. Now you might wonder if there's something arbitrary about the fact that we do these operations left to right. And the answer is actually, there's nothing arbitrary about it. And the key for seeing that is that we can change the subtraction to the addition. So let's take 4 minus 2 plus 5, and let's rewrite that as 4 plus negative 2 plus 5. And let's see if it makes a difference, the order in which we do the addition this time. If we find 4 plus negative 2 plus 5, and we perform the operations left to right, 4 plus negative 2 is 2. Then when we add 5, we end up with 7. If, on the other hand, we had decided to first add the two numbers on the right, that would have resulted in 3. Negative 2 plus 5 is 3. When 3 is added to 4, we also get 7. So it turns out that if the only operation is addition, it doesn't matter which order you do the addition in. You get 7 either way. That's good news. That's something called the associative property, which we're going to talk about in a minute. Also, since when we do change this to addition, we get 7 no matter which order we do the addition, it's important that we get 7 when we have it written as subtraction as well. And the only way we get 7 when we have it written as subtraction is if we perform the operations left to right. Now, I just mentioned something called the associative property, and that's what we're going to talk about next, the associative properties of addition and multiplication. Let's consider the sum 4 plus 2 plus 5. By order of operations, we know that we're supposed to technically first find 4 plus 2 and then add 5. But intuitively, if you think about it, we know we'll get the same thing if we first add 2 and 5 and then add that to 4. It doesn't matter which two numbers we add first. In either case, we end up with 11. So these two expressions are equal to one another. And if we think about this, it wouldn't matter what number 4 was. It could be some number, let's call it A. And what the number 2 was, it could be some number, we call it B. And what the number 5 is, it could be some number, we call it C. This property would always hold that the sum of A and B added to C is equal to the sum of B and C added to A. If A, B, and C are any real numbers, then we have what's called the associative property of addition. The sum of A and B plus C equals the sum of B and C added to A. There's a similar property for multiplication. The associative property of multiplication says that the product of A and B multiplied by C is equal to the product of B and C multiplied by A. Let's show the associative property for multiplication with some numbers. If we take -3 multiplied by the product of 4 and 6, that's the same as -3 times 24, which is -72. On the other hand, if we take the product of -3 and 4 and multiply by 6, that's -12 multiplied by 6, which is also -72. So we have shown that at least with these three numbers, the associative property is true, and I think it's pretty easy to swallow that this would be true no matter what the three numbers are. It's important that you remember that the associative property only applies to products or sums. If all you're doing is addition, the associative property applies. If all you're doing is multiplication, the associative property applies. For example, if I try to apply the associative property to subtraction, everything goes kaplooey. Let's compare these two expressions. In the expression on the left, the grouping symbols are around the second two numbers. In the expression on the right, the grouping symbols are around the first two numbers. When the grouping symbols are around the second two numbers, the first thing we have to do is 8 minus 4, which is 4, and so we're left with 12 minus 4. When the grouping symbols are around the first two numbers, the first thing we have to do is 12 minus 8, which is 4, and we're left with 4 minus 4. And you all know that 12 minus 4 and 4 minus 4, they're not equal to each other. The associative property doesn't work for subtraction. The associative property does not apply to division. Same situation, different symbol, division symbol. On the left side, the grouping symbols are around the right two numbers. And when we do 8 divided by 2, we get 4, so the left side is 16 divided by 4. On the right side, the grouping symbols are around the left two numbers. And when we perform 16 divided by 8, we get 2, and so we're left with 2 divided by 2. And again, one thing's for sure, 16 divided by 4 and 2 divided by 2, they're not equal to each other. The associative property does not apply when the operations are mixed. In this expression, I have both addition and multiplication. When the grouping symbols are around the second two numbers, I have to perform the addition first, which results in 3 times 5. When the grouping symbols are around the first two numbers, I have to perform the multiplication first, and the net result is 3 plus 4. And for the third time, you know that 3 times 5 and 3 plus 4, they're not equal to each other. The order of the parentheses is vitally important when you have subtraction, when you have division, or when you have mixed operations. However, if it's just addition, the location of the parentheses, the grouping symbols, is irrelevant. And when you have multiplication, the location of the grouping symbols is irrelevant. You end up with the same result regardless of which one of the operations you perform first. Alrighty, let's move on to the commutative properties of addition and multiplication. Let's begin with the commutative property of addition. If I take 2 objects and add 5 objects, and Candace takes 5 objects and adds 2 objects, guess what? Both of us have 7 objects. 2 plus 5 equals 5 plus 2. This would be true no matter what the 2 numbers in the sum were. If 2 was any number, let's call it A, and 5 was any number, let's call it B, then A plus B would equal B plus A. We get a similar occurrence with multiplication. Let's say I have 3 objects, and I count those objects 4 times. This is a graphical representation of 4 times 3, and we all know that 4 times 3 is 12. Well, let's turn this picture around, so to speak. Let's change it into 4 objects counted 3 times. 4 objects counted 3 times is a representation of 3 times 4. And once again, 3 times 4 is 12. What's my point? My point is that 3 times 4 equals 4 times 3. And this would be true no matter what the 2 numbers in the product are. 3 could be any number, call it A. 4 could be any number, call it B. And A times B would equal B times A. So we have our 2 commutative properties. If A and B are any real numbers, then the commutative property of addition says that A plus B equals B plus A. And the commutative property of multiplication says that A times B equals B times A. Just like with the associative properties, it's important that you remember that the commutative property only applies to products or sums. If we try to apply the commutative property to subtraction, everything goes kerplunk. 10 minus 8, 8 minus 10, they're not equal to each other because 2 does not equal negative 2. Everything's a muck when we try to apply the commutative property to division. 9 divided by 3 is 3. 3 divided by 9 can be represented as the fraction 3/9, and it's true that the fraction 3/9 reduces, but that's not the point. The point is that 3 and 3/9, they're not equal to each other. Subtraction, no commutative property. Division, no commutative property. You're going to have to make sure that you really know which property is the commutative property and which property is the associative property. Because if you don't really know which property is which, every time you hear somebody use one of those 2 phrases or you read one of those 2 phrases, you won't really know what the person is trying to communicate. So I'm going to talk about a little mnemonic that you can use to tell the difference between the 2. Before I get to that, I need to bring up another property. This is something that we call the reflexive property of equality. The reflexive property of equality says that any mathematical expression equals itself. The number 3 equals the number 3. The expression 2 minus x equals the expression 2 minus x. This is called the reflexive property of equality. So I'm going to begin my mnemonic illustration by making the reflexive statement that A plus B equals A plus B. How can we use this to illustrate the commutative property of addition? Well, you see the A and the B on the right side of the reflexive statement A plus B equals A plus B? The A and the B, they're going to take a commute. Pretty slick. Now we have the commutative property. A plus B equals B plus A because A and B took a commute. How about the associative property of addition? I haven't written it down yet. All I've written down so far is the reflexive statement that the sum of A and B If you add C to that, you get the sum of A and B if you add C to that. So how are we going to turn this into the associative property? Well, on the right side, we're going to focus on the letter B. B is going to change its mind about who it wants to associate with. B is tired of associating with A. B wants to associate with C. The associative property is all about who the term in the middle chooses to associate with. Commutative property is order. Associative property is parentheses. Whatever works for your memory, just memorize which property is which. It turns out that when these two properties are put together, they're really, really powerful. Because when applied enough times, the commutative and associative properties can be used to establish that the sum of several numbers or the product of several numbers may be performed in any order and with any grouping you choose. Now make sure you understand that this is saying if we have a sum and nothing else, we can do the sum in any order we want. And if we have a product and nothing else, we can do the computation in any order that we want. If we start mixing operations, this slide goes out the window. Let's evaluate 4 minus 12 minus 8 plus 30 minus 15 using the commutative and associative properties. Now hopefully you're thinking, wait a second, you said that you can't use those properties when subtraction is involved. You're right, I can't. So the first thing I need to do is change this to a strictly addition problem. Let's take 4 minus 12 minus 8 plus 30 minus 15, and let's rewrite it as 4 plus negative 12 plus negative 8 plus 30 plus negative 15. Now what the last slide said is that when the only operation involved is addition, I can perform the addition in any order I want and in any grouping I want. So what I'm going to do here is I am going to add the positive numbers together, add the negative numbers together, and then add those two results. So I'm going to take the 4 plus the 30, I'm going to add those two numbers together. I'm going to take the negative 12, the negative 8, the negative 15. I'm going to add those three numbers together. And then the last thing I'm going to do is add those two results. When I add 4 and 30, I get 34. When I add my three negative numbers together, since all three numbers are negative, I know that the result is going to be negative. And to get the magnitude of the number, all I need to do is add the three absolute values. 12 and 8 is 20, 20 and 15 is 35. And when I take 34 and I add negative 35, I get negative 1. To me, when I have a bunch of addition and subtraction to perform, this is the easiest way to do the computation. Add the positive numbers, add the numbers that are being subtracted, and then just subtract the final result from the first result. Now let's talk about the distributive property. Let's compare 3 times 2 plus 4 with 3 times 2 plus 3 times 4. Because of the order of operations, we know that 3 times the sum of 2 and 4 is 3 times 6, because we have to do what's in the grouping symbols first. Similarly, because of order of operations, we know that 3 times 2 plus 3 times 4 is 6 plus 12, because multiplication takes priority over addition. You have to perform the multiplication before the addition. Let's look at this in a little more detail. 3 times the sum of 2 and 4 is 3 times 6. And if we think of multiplication as repeated addition, 3 times 6 is just the sum of 3 6s. On the other hand, 3 times 2 plus 3 times 4 is 6 plus 12. Let's get a little image to think about what 3 times 2 plus 3 times 4 really means. 3 times 2 means that we're going to start with 2 objects, and we're going to count those 2 objects 3 times. 3 times 4 means we're going to start with 4 objects, and we're going to count those 4 objects 3 times. So when we add our 3 times 2 to our 3 times 4, check out what we have. We have 6 objects counted 3 times. We have 6 plus 6 plus 6. Pretty darn slick. 3 times the sum of 2 and 4 equals 3 times 2 plus 3 times 4. This would be true if 3 was any number, call it A. If 2 was any number, call it B. And if 4 was any number, call it C. A times the sum of B and C equals the product of A and B added to the product of A and C. This is called the distributive property. And a little more specifically, we say that multiplication distributes over addition. Multiplication also distributes over subtraction. A times B minus C equals A times B minus A times C. This really is just a special case of the distributive property of multiplication over addition. A times B plus the opposite of C equals A times B plus A times the opposite of C. But because we see subtraction so often, it's worth remembering that not only does multiplication distribute over addition, multiplication also distributes over subtraction. Let's put some of these rules together. Let's show that 16 minus 7 times 4 equals 16 times 4 minus 7 times 4. Let's first do it just by calculating. So if we take 16 minus 7 times 4, that is 9 times 4, which is 36. If we take 16 times 4 minus 7 times 4, order of operations says do the products first, so that's going to give us 64 minus 28, which is 36. Since both arithmetic expressions result in 36, they're equal. Let's use our rules to establish that these are equal. If we start with 16 minus 7 times 4, the commutative property of multiplication says that this is going to be equivalent to or equal to 4 times 16 minus 7. And now the fact that multiplication distributes over subtraction gives us that this equals 4 times 16 minus 4 times 7. And since we have to do the multiplications first, we can apply the commutative property of multiplication to each of these products. And we have 16 times 4 minus 7 times 4. Now, I am not suggesting that you would ever want to go through these steps to calculate 16 minus 7 times 4. I'm just trying to show you that we can use the properties to establish the equivalence of these two expressions. Let's notice that the upshot here is that multiplication distributes over subtraction and addition regardless of which side of the product the addition or subtraction is occurring. So if A, B, and C are any real numbers, then we can say A times B plus or minus C equals A times B plus or minus A times C. This symbol might be new to you. What this symbol is saying is that either we have a plus sign on both sides of this equal sign, or we have a minus sign on each side of this equal sign. This property is true even if the sum or difference is on the left side of the product. B plus or minus C times A equals B times A plus or minus c times a. You know, fractions turns out to be related to the distributive property. It turns out that the addition or subtraction of fractions with a common denominator is just a special case of the distributive property. And that's pretty darn cool. Let's consider 3/5 plus 4/5 equals 3 plus 4 over 5. Let's start with the right side of this equation. If we take 3 plus 4 over 5 and rewrite this as a division problem, when you rewrite a fraction as a division problem, you need to take the numerator and divide by the denominator. Now hopefully you're a little wary of what I've written here because you're thinking, you know what, division happens before addition. And you're right, it does. And I don't want to just divide the 4 by 5. I want the whole sum, 3 plus 4, to be divided by 5. And the only way I can communicate that is to put the 3 plus 4 inside some sort of grouping symbol. All right, so now I have the sum, 3 and 4, divided by 5. I can rewrite that as a product, 3 plus 4 multiplied by 1/5. Now I can use the distributive property to rewrite this as 3 times 1/5 plus 4 times 1/5. And I can take each one of these products and rewrite it as a division. 3 times the reciprocal of 5 is the same as 3 divided by 5. And 4 times the reciprocal of 5 is the same as 4 divided by 5. And written as fractions, 3 divided by 5 is 3 over 5, and 4 divided by 5 is 4 over 5. Now again, I'm not suggesting that you would ever go through these steps, ever. I'm just trying to show you that the addition of two fractions with the same denominator is really nothing more than the distributive property, the fact that multiplication distributes over addition. But we have to be careful when we try applying the distributive property when division is involved. If we take 12 divided by 2 and add 12 divided by 4, because of order of operation, this is 6 plus 3, which is 9. On the other hand, if we take 12 divided by 2 plus 4, I need to do the sum first because it's in parentheses. So this is going to be 12 divided by 6, which is 2. So this time, the division is not distributing over the addition. It turns out that division distributes over addition only if the addition is on the left side of the division, only if the addition is on the left side of the division. What went wrong in the last example from a fraction perspective is that when I write 12 divided by the sum of 2 and 4 as a fraction, that's 12 over 2 plus 4. 12 divided by 2 is 12 over 2, and 12 divided by 4 is 12 over 4, and hopefully, you know, when you add fractions, you don't just add the denominator. That's why this distributive property is not working when the sum is on the right side. When the sum is on the left side, the sum ends up in the numerator of the fraction. And when you add two fractions with common denominators, you do add the numerators. And that's why this distributive property about division works when the sum is on the left side of the division. Now, all of this might seem a little bit confusing, and that's okay, because you know what I'm going to suggest? I'm going to suggest that you just don't think about division and the distributive property, since it really is just a special case of fraction addition and subtraction. And you're going to find out that this division symbol, it's going to go out the window almost immediately, because in algebra, it's much easier to work with fractions than it is to work with division. So what you'd really need to remember are these three properties: the associative property of addition and the associative property of multiplication, both of which have to do with parentheses, the commutative properties of addition and multiplication, both of which have to do with order, and the distributive property, the fact that multiplication distributes over both addition and subtraction. I'm going to turn it over to Candace now so that she can talk to you about order of operations some more.